Well, I guess now I'm quite visible and audible both. Let's then start the chapter scale and maps. Well, here are some like contents that tells us the actual distance. Well, first of all, let's talk about scale. What is a scale? Alright, so a scale is something that tells us the actual distance represented by the same line on the map. So what does that mean? That means a scale simply tells us what the actual distance. Say for example, if I mention 2 kilometer long road, alright, so you can't like represent that on a single page. It would take you whole lots of pages in it. So in that sense right there, you need to adjust the 2 kilometer length according to your will so that it fits right onto this page. It is like this line can be of 2 kilometer, this line can be of 2 kilometer, but this line is a fraction of the real 2 kilometer distance. So what is the fraction? When we write the fraction in form of ratio, that is the scale. Alright, we have two types of scales. One is linear scale, or you can call linear scale. Another one is area scale. Well, the area scale is derived from the linear scale. When we square, of course, both sides and the units. I've seen many students, they just square the both sides, but they forget the units. So when we square the linear scale, it gives us the area scale. And both scales have different uses. When we are when we are talking about the dimensions and lines and lengths, breadths, widths, heights, etc. At the time we talk about linear scale, the dimensions, the length, breadth, height. At the time we talk about linear scale. And when we talk about area, for calculating the area of map or actual area or anything about area, anything concerning the area, that is when we use area scale. I will go into greater details later that when to use area scale, when to use linear scale. So in that sense, let's discuss what is the definition of area scale. It is the square of linear scale. And what is linear scale? Linear scale is a straight connection. Linear scale is a straight connection between small map line and actual real life big line in the form of ratio. So I guess you have understood that. What is area scale? This is the square of linear scale. What is the linear scale? The straight direct connection between a small map line and actual real life big line in the form of ratio. Alright, so there difference. Here we have some maths related to linear scale. If I just give an example, say example 1, scale given is 1 cm to 3 kilometer. So let us first understand the question. So what is 1 cm to 3 kilometer? That means 1 cm, like 1 centimeter in this page, represents 3 kilometer of a long actual road. The road is actually too big to be able to fit in this page. So in that sense, we're considering each centimeter, each 1 centimeter as 3 kilometer. So if we draw a 9 kilometer line, if we want to draw if we want to represent 9 kilometer on this page, how should we represent that? Actually, yeah, that's true, you're correct. So in that sense, we have to write like that: 1 is to 3, 2 is to 6, 3 is to 9. That means a 3 centimeter long line will represent a 9 kilometer long line. You get me? 3 cm line on this page will represent a 9 kilometer long road. I hope that is clear. So let's go on to the question. So find the length representing 7.5 kilometers. If you can do it, pause the video right now and just try and solve it. Otherwise, let's go through it step by step. Well, if I talk about this, here are some steps in this math. Say, if I can mention it, if you follow it stepwise, so you're gonna master it really quick. Okay, step 1 goes like this. First, write the given scale. First, write the given scale. But how to write the given scale? Such that the needed unit stays on right hand side. I hope students, you are currently familiar. Yes, you're familiar with the unitary method. Okay, until the unit stays on right hand side. So what do I mean by that? Right, so simply what I mean by that is, the question asks for find the length representing 7.5 kilometer. What is this? Actual. This is the actual, right? Actual, because this is kilometer. 7.5 kilometer cannot be represented on this page. That means this is the actual. So the question asks for finding the length that represents this long road. Okay, we have to find the length that represents, that means the map length is required to find the map length. So what is required to find is the map length, and what is the required unit? For the required unit, we need to look at the scale. The scale is given in kilometer to centimeter. So kilometer is given to us, so what is needed right now? Centimeter is needed right now. So the needed unit means centimeter here. So centimeter must stay on right hand side. So how do we do that? We do that by writing the scale like this: 3 kilometer to 1 centimeter. Now look, the centimeter is the required unit and it is on the right hand side. Condition fulfilled. Then we proceed on to the step 2 right now. So you see, next step would be write the given length. Write the given length matching the above unit. The above units. What do I mean by that? I think you guys are familiar with the unitary method, so this won't be a problem for you. But for those who aren't familiar, just follow the process like that. Kilometer to 1 cm, I will write like this. Here it asks me for the centimeter one, right? Kilometer one is given, right? The kilometer one is already given. So what I need to do is, we have to match the kilometer to kilometer. We have to write it 3 kilometer and 7.5, my bad, 7.5 kilometer right underneath that. Okay, then you can give 2, and then follow the unitary method. Those who do not understand the unitary method, no need to worry, just simply follow the process. Write this correctly. The needed unit should be on the right hand side, and then you have to write the scale yet again, and then write the matching units underneath it. You have the units for kilometers, so I've written the kilometer right here, but I don't have the centimeter. I need to find the centimeter right now. So what I'm gonna do is first take the 1/3, multiply with 7.5. This is the way. Just bring it down. This would go down, and this would go on and multiply with the whole lot of things. All right. So this is the way we just carry on with the unitary method process. Those who do not understand, I would hopefully post a new video on unitary method. So let's get on with this scales. So what I did here is 1/3, because 1 is right there. Just put it right here, and 3 will go under 1, and then multiply it with 7.5. Okay, what will you get? Let me check. 1/3 times 7.5, that gives me 2.5. This 2.5, what would be the unit, students? Anyone? Yeah, it would be centimeter, because here you see 1/3, 1 is in centimeter, 3 is in kilometer, and 7.5 is in kilometer as well. Kilometer cut, that leaves behind centimeter, that will stay here. So this is the answer, 2.5 centimeter. This is how we just do the process, and we just do the math in 2 steps. So you can just follow the 2 steps to find the actual dimension from linear scale. Alright, then we move on to this thing called area scale. So as I have already mentioned, that area scale, as I've mentioned here, area scale is the square of linear scale. So what do? We do is simply, let's take an example of, say the given scale is suppose 2 kilometer to 2 centimeter to 1 kilometer, my bad, 2 centimeter to 1 kilometer. The question asks for find the area scale. My handwriting is bad, but don't mind that. Yes, you won't mind that. Well, in that sense, first what we have to do is we need to find the area scale right here. Alright, we need to find the area scale. Why? Because the dimensions are not mentioned here. So it says area scale, so we have to find the area scale. So the steps are basically, we have to write the linear scale, write the linear scale as ratio. So how do we do that? 2 centimeter, 1 kilometer, just nothing. We just have to write it this way, and instead of the 2, we just have to give 2 dots like that, the ratio sign, you know, this is the ratio sign. Alright, I have to write it like that. Afterwards, step 2, in step 2 what we need to do is square both sides. We need to square both sides and remember the units. I've seen students who just miss the units and just mess up with the math. With the width along with units. So how do we do that? 2 centimeter is to 1 kilometer. Squaring both sides, square, 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 square. That gives us 2 square. What is that, students? 2 square is 4. 2 into 2 is 4. Then 4 centimeter square is to 1 square is 1 kilometer square. So when we have square, the square represents that we just now have the area scale. When you will see the squares, okay, be sure that the square means they are from area, they're representatives from area group, I guess. I'm just kidding, but yeah, this is the area scale that I have found. So math done. Okay, the math is done. But what if it says like, what if the question extends that, if the question says like, if given that map area is 16 kilometers square, find actual area. Well, this is the question. All right, so in that sense you have to do a few more steps, like step 3, that is, if map area is given, that means just you simply need to do what we did in with the linear scale. We have to find first, write the area scale. Okay, this is not working. Okay, please. Area scale such that the area stays on, I must say the needed area stays on y. Well, yeah, that's it. So how do we do that? Just similar to the one we did just before. The given units such that needed unit stays on right, needed area stays on right. How do we write that? What do we need? The question gave us map area. We have to find the actual area. So here, tell me students, which one is the map area, which one is the actual area? In that sense, I am giving you a bit trick. The trick is, the map area is usually the smaller unit. This is the smaller unit, that's the map area. This is the larger unit, that's the actual area. So what do we have to write is the needed area. What is the needed area? The actual area is the needed area because it is required. Oh, sorry, my bad. The question is, it would be a bit twisted, like 16 centimeter, my bad. Find the actual area. So we have the centimeter square. Okay, let me explain it to you again. It's like the needed area. What is the needed area? The actual area is the needed area. So the actual area's unit is kilometer square. So the kilometer square must be on right hand side. So the scale, we have to write it. It doesn't change like that. Just write it like that. We don't need to change it. 1 kilometer square is already on the right hand side, so it stays on the right hand side. So step 4, here we go. What we have to do is write the same thing as linear scale. Write the given units matching the above area scale units. What's meant by that? Simply nothing, as we did. Write the area scale and what is given, 16 centimeter square. Write centimeter square under centimeter square, give is to whatever you want. Then, as I've mentioned, the unitary method, what we have to do is whatever stays on right hand side must go up, whatever stays on left hand side must go down, whatever stays on left hand side of the second line must be multiplied. And tell me what will be the units, my brilliant students. It would be, of course, it would be kilometer square, because centimeter square and centimeter square would be cut, only kilometer square remains. That gives us 4 kilometer square, I guess. 4 kilometer square is the actual area that is represented by the 16 centimeter square on the map. So this is it, and this is the process actually how we do the linear scale and actual scale. And now currently we would be heading to some maths probably, but before that I need to tell you that when to use area scale and when to use linear scale. area scale is used when area is given to you. Just look at the example right here. It says the map area has been given to you. So the map area has been given to you and no other lengths are provided. Okay, when no other lengths are provided to you but only the area is provided to you and you are required to find the actual area, okay, or vice versa. So what you have to do, use the area scale. But when you're provided with the actual lengths, when you are provided with the actual length, or when you are provided with the map dimensions, the map length and breadth, just don't go for the area scale right away. Alright, just try to solve it using the linear scale, and also use your area, the formulas that you have. For rectangle we have length multiply breadth, and for squares we have length multiply length. This kind of formulas you have to use. Just when you see the area, just right away don't jump into the area scale. All right, first look at the question. The question did not give you any of the dimensions, right? Did it give you any of the dimensions? No. So is there any other way to find the area? From our childhood we have understood that there are two ways of there are only one way. There is only one way to find the area, that is using the formula of area, right? So area formula for rectangle is length into breadth, and length and breadth are called dimensions. So these dimensions are not provided to you, so you cannot find the actual area right away. So what you have to do is use the area scale right here. Why? Because the dimensions are not provided to you, the length and breadth are not given in this question. For that reason you will have to use the area scale method right here. But if the dimensions are given to you, just don't jump straight away to area scale. Just try with the area formula. Just try multiplying length and breadth to find actual area or map area, then proceed with the area scale or the linear scale according to your questions. So that's it for scales and maps. So if you need some more examples, I would be providing. I would like to know your comments. Thank you, students. Take care.